What's going on, guys? Let's look at these problems right here. Here the question is asking for the following complex numbers, find either their algebraic expression in RA and imaginary parts, or their polar form with their magnitudes and arguments. If you look at the first one is already given in the polar form, or you can say Cartesian form. It's given in that. Now, what is RA? RA can be calculated using Pythagorean theorem, because if you look at this, here we have the real part and the imaginary part. If we draw this in a graph, it's going to look like this. Imaginary is always y-axis and the real part is always x-axis. Imaginary 4, positive 4, so it's going to be here, and the real part is 3, so it's going to be somewhere here, and this is the number. Okay, now to find out RA, we have to use the Pythagorean theorem. RA, Pythagorean theorem is basically, we find the magnitude of this length, right? We know that it's x square plus y square. We know x is 3 square, plus y is 4 square. 16 plus 9 is 25. Square root of 25 is 5. So R of A is 5. And then also we can calculate the angle that's making from here to here by using the tan theta. Tan theta is y over x. Y is 4 over 3. So theta is going to be tan inverse 4 over 3, and whatever the angle you get from this is going to be the angle of this. That's the first part. Now let's look at the second part. Second part is given in an exponential form. In exponential form, if we have an exponential form, it's always r, the first number is r, and e power j theta. J theta, this is the angle and this is the r. Okay, here it says if it's in the polar form, we have to find out RA and the angle. We found out both. This is our RA for the first one, and the angle is, whenever you whatever you plug in calculator, you will get tan inverse 4 over 3. You will get the value of angle. But let's look at the second part. Second part, we have 10. This is in exponential form, so we can find the polar form of this one. Polar form. Okay, polar form. Let's to do that, we have to use the Euler's theorem. Euler's theorem says if we have a number like this, it can be expanded as r and cos theta. Cos, the angle is 5 over 3, cos 5 by 3 plus j sine the angle 5 by 3. So 10 5 by 3 is half, and then sine 5 by 3 is root 3 by 2. So j root 3 by 2, and if we multiply, this is going to be 5 plus 5 root 3 j. 5 root 3 j. This is the polar form of the second one. Now let's look at the third one. Third one is given in Cartesian form. 1.5 plus 2.5 j. Again, we can put it like this in a graph. First number is real part. Real part is always in the x-axis, 1.5, and the second one is imaginary in the y-axis, 2.5, and this is the length we have to calculate. To calculate the length, we can use the Pythagorean theorem. R of A is equal to 1.5 square plus 2.5 square, and if you square these two and square root, this is going to be just square root of 1.5 square plus 2.5 square. It comes out to be, let me ask Siri. Hey Siri, 1.5 square plus 2.5 square.
The answer is 8.5.
Okay, this is 8.5. Square root of 8.5. Okay. And yeah, we can also find out. Hey Siri, what's the square root of 8.5?
The square root of 8.5 is 2.91548.
2.91548. Okay, this is the answer. And the angle we can calculate again. Tan theta is y over x. Y is 2.5, x is 1.5. So theta is going to be tan inverse 2.5 over 1.5. Okay, maybe I can ask that from Siri as well. Hey Siri, what is 2.5 over 1.5?
2.5015 times 1.5 is 3.75225.
No. Hey Siri, 2.5 divided by 1.5?
2.5 divided by 1.5 is about 1.6666.
Hey Siri, tan inverse of 1.666.
Okay, I found this on the web for tan inverse of 1.666.
Hey Siri, hey Siri, hey Siri, tan inverse of 1.66.
Okay, I found this on the web for tan inverse of 1.66.
Okay,
Check it out.
Siri says tan inverse, it's tan inverse, so I leave it to you. Theta is equal to tan inverse 1.666, and whatever the angle you calculate is going to be the angle from here to here. That's how we do that. If we have in the polar form, it's given in the polar form, or you can say rectangular form. We just try to calculate RA, the length of this line. That can be calculated using the Pythagorean theorem, and the angle can be calculated using by taking tan theta. Tan theta is y over x, y divided by x, and then theta can be calculated by taking the inverse of tan inverse of y over x. You have to do the same thing for this one. 1 and 3 are same thing, and for the 2 they have given in the exponential form. You can detect exponential form by seeing the e power. If you have seen a number and e power j something, it's in exponential form. And the first value, we can use the Euler's theorem. Euler's theorem says r remain the same. Then you have to take the cos theta. Cos theta is going to be the real part, cos 5 over 3 plus j sine 5 over 3. Yeah, and then we did that one right over here, and that's how we do that. I hope you guys find this video helpful. Thanks for watching, and see you next time.